Hey everyone, I'm Andrew and my partner is Hannah, and we're going to be talking about regression analysis. So before we get into it, we're just going to do quick intros. I'm Andrew, as I said, and I study industrial engineering and data science.
Hi, I'm Hannah, and I study social policy, statistics, and business institutions. So first, we're going to be talking about regression analysis, and kind of a brief explanation of what that is using statistical models to interpret how data relates to each other and to assess how much they are related. So when to use regression? There are a variety of reasons to use regression. Most importantly, when you're working with large data sets, it's important to kind of understand the data, which which is what regression is used for. So, through regression, you can also understand which inputs matter most to impacting the outcome. Also, you can use regression to describe relationships between certain input and output variables. So, understanding the magnitude of the input, but also kind of more in depth on what that relationship actually looks like. And then the purpose here is to predict future outcomes as well as classify the data. So you can really take that large data set and use it for different purposes. Also, when you're creating regression models, it's really important to, can you go to the next? It's really important to assess the model itself to make sure that it is a valid model as well as being an accurate model. So there are some initial interpretations you can do, especially kind of understanding if your input variables are correlating to your outcome. So, that means as one goes up, the other also goes up. Or if you have more of a cause and effect relationship where the input variables are actually causing the output variable to react the way it does. Next, once kind of understanding that high level analysis of your regression model, you want to do more model diagnostics. So, that especially means testing for normality and randomness of the data, as well as using the residuals to understand the data and confidence intervals. And a lot of those tests include the t-test, f-test, and partial f-test, and kind of different variations of those tests and processes in order to validate the data, validate the model, make sure that it makes sense with the data. And then lastly, when you kind of get your conclusions from those model diagnostic tests, that's when you're going to refine the initial model. So that could mean actually going with a completely different model, or that could mean adding in or taking away new variables or interaction terms. And yeah, so that's kind of the main assessment procedures that we have for regression models.
So now we're going to look at some of the types of models used for regression. And these are all models that Hannah and I have worked with before. And they each kind of have their own strengths and weaknesses. So the first is a basic linear regression, which just models linear relationships between the variables in the output. The next is the logistic regression, which is commonly used for categorical outcomes. And this is because when you have outcomes that are, say, like yes or no response, you can't actually make those or quantify those outcomes into numbers. So you need something like a logistic model. Polynomial models are good for improving the accuracy of predictions by gaining flexibility when you add certain terms like quadratic variables or interaction terms, as Hannah was talking about before. And the last two are a bit more advanced, but they're actually really useful when you have lots of data. The first is neural networks. This takes a lot of computational power, but it also has the highest predictive power. So often you see neural networks being used when you want a really, really accurate model. And the last one is trees, which are great for interpretability, as we'll go into an example and see why in just a moment. So our example is focusing on a study from prostate cancer subjects. So the outcome is the PSA over here, and then the volume, weight, and penetration are the three input variables. So now I'm going to switch over to R and actually show you how we do this regression. So here we're in R, and we're basically looking at some of the functions which kind of basically create this tree that we're looking at. And so this is our model, and this is it visualized. And so it looks kind of like a tree. We have these branches here. We have what we call splits, which are the conditional statements. And then we have the nodes at the bottom. And these nodes are the actual predicted outcomes. So if you're going to interpret this, you basically want to look at each statement, and it's either going to be true or false. And based on that, you'll take one branch or the other branch. And you keep doing this until you get to a predicted response. So let's say the volume of our subject was greater than 16.78, then you would just take this branch here, and then you would have an outcome of 102.8. So like I said before, trees are very interpretable, but this is just one type of regression. As we talked about before, there are many other types, and you can really analyze any sort of data when using regression. So that's our tutorial, and thanks for listening.